Hello guys, welcome back to my YouTube channel Anveshan Academy. This is Dr. Manjunath Chennapkot. Dear students, in the previous class we solved one numerical on thermal conductivity. Okay, so come we'll move towards numerical number 2 on conduction heat transfer. Okay, so numerical number 3. Dear students, I will first read the problem. Then I will solve this numerical step by step. Determine the heat flow across a plane wall of 10 cm thickness with a constant thermal conductivity 8.5 watt per meter Kelvin when the surface temperatures are steady at 100 degrees Celsius and 30 degrees Celsius. The wall area is 3 meters square. Full stop. Also find the temperature gradient in the flow of direction. Okay, dear student, this is the given problem. Now what I have to do? I need to draw the schematic diagram for the given problem. Then I need to list out the given data. Then I need to write down the relevant equation to solve this numerical. So what I will do, dear students, I will draw a diagram. So dear students, you can see now there is a plane wall. Yes, I will take there is a plane wall. In that plane wall having a thickness of that thickness you can mark here as a 10 centimeter. Or in meter it is 0.1 meter. Okay, then one end we are going to supply heat. That heat is going to transfer across the wall, okay, of thickness 10 centimeter, and it is going to have some thermal conductivity. That thermal conductivity we can mark here as a K, that is 8.5 watt per meter Kelvin he has given. Then heat is going to transfer steady. That means what? Constant heat is going to takes place here. That means what? Temperature remains same, that is constant, steady state. Okay, one end temperature is 100 degrees Celsius, then at other end it is what? How much, dear students? That is he has given 30 degree Celsius. 30 degree Celsius. Heat is going to transfer from 100 degree Celsius to 30 degree Celsius. Then he is telling that there is a area of the plate. That area of the plate he can mark is a A. That A is equal to, that is in meter square, that is equal to how much he has given? 3 he has given. That means for 3 meter square he has given, dear students. This is the plane wall. Okay, then what actually is asking? Is asking to calculate the heat flow, first parameter. Second parameter, temperature gradient in the direction of heat flow. This is the problem he has given, dear students. Now what you have to do? You have to draw the schematic diagram for this particular problem. How it is, that you can see here now, dear students. Okay, now I will draw the diagram here now. So that means what? This is a plane wall, this is one end. So it is what? My high temperature region. So that high temperature region I will mark here as a T1. So then low temperature region I will mark here as a T2. The heat is moving from left to right. That means what? In this direction, that heat direction I will show it here. That is flowing from high temperature region to low temperature region, that is T1 and T2. That material, that plane wall having a thermal conductivity, I will represent here thermal conductivity K. Then initial point, that distance I will mark here as a x1, then final distance I will mark here as a x2. So when we are going to x2 minus x1, right, then what we are going to get? We are going to get the thickness of the plate. The thickness of the plate we can mark here as a L, or dx you can take, or you can take T. When it is heat is flowing, right, from this high temperature region, that is T1 to T2, right, then what happens now? There is a resistance in the flow of heat direction. That resistance I can show it here now. Initial temperature will be T1 and our final temperature is T2. There is a resistance in the flow of heat that I can represent with the help of thermal circuit. That is thermal circuit we can see here, dear students, now. So it is what? Starting point. What is the temperature here? I will mark here as T1. Then here it is a T2. Then there is a resistance offered in the plate. I will mark here as a R or R1 you can take. I will take R here now. So then heat is moving in this direction. That heat I will show it here Q actually. This is what? The diagram, schematic diagram and thermal circuit I have drawn for the particular problem. Now what I will do, dear students, I will list out the given data. What is the L? What is L here now? He has given. What is L? Thickness of the plate. How much he has given, dear students? That is L. That he has given, it is in 10 centimeter he has given. That you need to convert it into meter. That is nothing but what? 10 centimeter is divided by what? 100. That wide. So 1 meter is equal to 100 centimeters. So I will divide it by 100. I am going to get here 0.1 meter, dear students. Okay, fine. Next, with a constant thermal conductivity, that plate having a thermal conductivity, that is K, right? That K is equal to how much? So I will write it there. Thermal conductivity of the plane wall is 8.5 watt per meter Kelvin he has given. Okay, fine. Next, when the temperature are steady, that means what? Temperature at this side is T1 and temperature at this side is T2. How much he has given? T1 and T2. So I will write it here. T1 is equal to how much he has given, dear students? 100 degrees Celsius he has given. I will convert it into Kelvin. Why so? Because thermal conductivity he has given in Kelvin. So what I will do? I will try to maintain the same uniformity. So for that purpose, what I will do? I will convert this degree Celsius into Kelvin by adding 273. Then what is the answer? 373 Kelvin is the temperature at high side, that is T1. So what is T2? T2 is equal to how much he has given? 30 degrees Celsius he has given. This is 30 degrees Celsius he has given. So 30 degrees Celsius can be converted into Kelvin by adding 273. Then how much you are going to get? You are going to get 303 Kelvin, dear students. Okay, fine. Next, this is the wall area. That means what? That wall having any area, that area we can mark here as a A. That means what? A also he has given. What is the area? The area of the plate or plane or wall, it is equal to 3 meters square he has given, dear students. Now, so I have listed now. K I have listed, thickness I have listed, T1, T2 I have listed, then area also I listed. Then what actually is asking? The first parameter to find what we need to find. To find first one, you need to calculate the rate of heat transfer, that is equal to heat flow. I can say a rate of heat transfer, that is Q is equal to how much. Second one is asking to calculate dt by dx is equal to how much? Temperature gradient. This is a given data I have taken. So now I will solve this numerical step by step, dear students. Okay, so first what I will do, I will try to calculate the first one, heat flow. So I will try to calculate the first one, heat flow or rate of heat. So that is what? So I will write it here, dear students. So what is that? We know already. It's a conduction heat transfer. So in the plane, heat is going to transfer. Hence the conduction heat transfer is there. That conduction heat transfer I can calculate with help of Fourier's equation. What is that? Minus Ka into dt by dx. Okay. So fine. Now what I will do, dear students, I will write it here now. So K into A. What is T2? dt. dt is nothing but what? Highest temperature minus lowest temperature. That is T2 minus T1. So what I will do now? I will write it here. I will remove T1 minus T2. So minus sign will be removed. So therefore T1 minus T2. Okay, T1 minus T2 divided by dx is nothing but what? My thickness of the plate, that is L. So now I will try to substitute the given data. What is K? K you can see here now 8.5. So I will write it here. K is equal to 8.5 into area he has given as a 3 meter square. Okay, fine. The next temperature he has given, highest temperature is 373 Kelvin minus lowest temperature, that is 303. Dear students, you can substitute degree Celsius or Kelvin, but the difference you are going to get the same. But I will try to maintain same uniformity. Hence what I have done, I have converted degree Celsius into Kelvin divided by what? L. L is equal to how much he has given? 10 centimeter he has given, that is nothing but what? 0.1 meter. Then do substitute, dear students. How I will substitute? In the calculator. Okay, now I will try calculate now. So 8.5 into 3 into what I can write, dear students, you can see here now. So 373 minus 303 into bracket, then divided by what? 0.1. How much you got? So 17850. So I will write it here. Q is equal to 17850. That is in watt, dear students. That is in watt. Okay. So next I can put that in terms of kilowatt also. So therefore what I can do? Q is equal to 17850. That is in terms of watt. Okay, the same thing I can express in terms of kilowatt. How it is kilowatt? That you can do, dear students, we can do engineering. 17.85 into 10 to the power of 3. 10 to the power of 3 is nothing but what? Kelvin. Kilo. So therefore what I can do here now? Q I can express here. Q is equal to 17.85 kilowatt I can write, dear students. This is my what? This is answer. Q is equal to, I can express in terms of watt or in terms of kilo. Okay, this is my first finding. Yes, answer is heat transfer is 17850 watt. Okay, second, now what is second parameter? So I need to calculate the temperature gradient. Okay, temperature gradient. What is temperature gradient, dear students? So that is nothing but dt by dx. So how I can write the dt by dx now? I will modify this equation. Okay, so we know the equation q is equal to minus k into dt by dx. So here is the dt by dx, so I will take it out. So therefore what I can do now? So therefore dt by dx is equal to I will shift this k into left side. Then what happens? q divided by minus is there. I will write it here minus k into a. Okay, fine. So now I can substitute the value dt by dx is equal to, what is q? Q already I have calculated, that is 17,850 watt actually. So I will write it here 17,850 watt minus is there, minus I will write it here. 1 minute. Okay, dt by dx is equal to minus 17850. What is k? K is equal to 8.5. He has given in the problem itself. Area also he has given, that is 3. Then do simplification. How much you are going to get? So okay, substitute 17850 divided by 8.5 into 3. How much you are getting? 700. So I will write it here dt by dx is equal to 700, but here minus is there. I will write it here minus 700 watt per sorry, 1 second. Okay, dear students, sorry, here it is not watt, so just a minute. It is what? dt is nothing but what? Change in temperature, that I have taken it in Kelvin per meter actually. So Kelvin per meter also I can express, or I can express degree Celsius per meter also. That is what? Temperature gradient. Then I can write it here, dear students, dt by dx is equal to, I can write it here 700 Kelvin per meter. So this is my final answer, dear students. Where what is this minus sign? Minus sign indicates what? Decrease in temperature. That I have already explained well in previous video. You can go and check. With the help of some sample readings I have explained. So that minus sign indicates what? Decreasing temperature. So therefore temperature gradient is dt by dx is equal to 700 Kelvin per meter, or we can express in terms of degree Celsius per meter also. This is how to solve the numerical. Dear students, if you understood, please do like, subscribe and share the videos. Thank you.